Hi everyone. Today we are going to present the advanced AI-driven technology text prediction. It is a technology that enhances the user's experience across the multiple applications by suggesting the new words, phrases, sentences in the real time. This is presented by Rikil Kumar Reddy Chavarapu and my friend Vasunita Someshkar.
Coming to the contents, our presentation includes introduction of the text prediction, working principle, traditional approaches to the text prediction, machine learning techniques and the deep learning techniques which are used in the text prediction, applications of the text prediction and the challenges which are faced in the text prediction, and finally the future trends in the text prediction. Introduction. Firstly, what is text prediction? Text prediction is a technology that suggests the next word or phrase as you type. It uses the artificial intelligence and the machine learning techniques to anticipate the user's intent. The main goal of text prediction is to enhance the typing efficiency and reduce the errors and improve the user experience. Why the text prediction is more important? Because it increases the speed, like to reduces the number of keystrokes which are needed, and it enhances the accuracy, the most important thing, like it minimizes the spelling and grammatical errors. Mainly it provides the contextual assistance by helping the users to express their thoughts ideas more effectively. Where the text prediction is used, it is used in a lot of applications, like mainly in search engines like Google, Yahoo, by providing the auto-complete suggestions to help the users to complete their queries. And it uses in the messaging apps like WhatsApp, Facebook, Google, Gmail, to quick type keyboard assistant in the composing the messages, and it is used in the chatbots and virtual assistants. AI assists like Siri, Alexa, and Google Assist use it to predict the text to enhance the conversations. And it is more helpful in the language translations. It is more important, like Google Translate and deep learning uses the prediction models to improve the translation fluency. And mainly in the code editors, like AI based tool like GitHub Copilot suggests the code snippet based on the context. How the text prediction works. Text prediction works by understanding the sequences in the text data. Mainly, the text prediction relies on the understanding the sequences of the words in a given language. AI models analyze the previous words and their relationship to predict what comes to the next. Mainly, it works by the role of probability in predicting the next word or the phrase. It uses the statistical models to compute the probability of each possible next words based on the past data. For example, let us consider a phrase. How are dash? What should be fit in the dash? The model assigns the probabilities for each word. For example, like you as 80%, we as 15%, and they has 5%. The system selects the word with the highest probability. Here you has 80% probability, so you will fit over there, and the system will complete the phrase how are you. That's how it works. And it works by the context awareness and the semantics, like the basic models consider only the previous few words, and it misses the long range dependencies. But the advanced models like ChatGPT or BERT, they analyze the entire sentences and the paragraphs for the better contextual understanding. For example, let us consider a phrase like I went to a bank to withdraw the money. Here, the AI understand the bank is a financial institution, not a river bank. So that's how The text prediction works. Traditional approaches to the text prediction. In the rule based systems, early the systems relied on the predefined grammar rules and the word dictionaries. For example, they use the spell check systems to correct the common mistakes, but they cannot adapt to new words and suggest the new words. And they struggle with the slang, informal language, and evolving writing the styles. Coming to the statistical language models. Firstly, n-gram models. It predicts the next word based on the previous en words. For example, a bigram model. It means n equal to 2. It predicts based on the previous word. For example, if you give the input as good, it predicts the morning based on the commonly used words. Large n values like diagram, foregram, it provides more accuracy and requires more computations. Markov models, it predicts more words using the probabilistic frameworks assuming the limited context. For example, the given phrase is the cat sat on the dash. The probability might be mat, floor, and sofa. Usually, the system check and fit the most probability word. Like mat has 70%, so mat will fit over there. But it cannot handle the long range dependencies and the lack due contextual understandings. Machine learning techniques in the text prediction. Firstly, supervised learning versus unsupervised learning. Supervised learning. AI models are trained on the label datasets like input output pairs. For example, feeding thousands of text messages to an AI and the labeling the correct word predictions. Coming to the unsupervised learning, the models learn patterns from the raw text without labeled examples. For example, training a model on the large text corpora like Wikipedia or news articles to learn the language patterns. And the second one is the future extraction techniques like TF-IDF, term frequency and inverse documentation frequency. It measures how important a word is within a document. It is basically used in the search engines and the text classification. Next one is the word embeddings like word to vec and glove and fast text, and it converts words into the dense numerical vectors that captures the meanings and the context. For example, king minus man plus woman equals to the queen. And the transformers like BERT and GPT, it understand the full sentence context, improving the accuracy. For example, BERT is a bidirectional. It means it looks at both previous and the next words for the context. And next, model training and evaluation. Training phase. AI models learn from massive text data sets. Like example, GPT models are trained on billions of sentences from books, articles, and online context. And coming to the evaluation matrix, like perplexity, it measures how well a model predicts a sample text. And blue a score, it evaluates the prediction accuracy compared on the human written text. My friend Vasu will continue the next slide.
Deep learning techniques. Recurrent neural networks. Reads text word by word, remembering past words. Limitation. Struggles with long sentences due to vanishing gradient problem. Second, long short-term memory. An improved version of recurrent neural networks with memory cells to store important information. And it can remember context over longer text. It's used in predictive typing, like for example, smartphone keywords and chatbots. Third, transformers. Bird, GPT, and DeFi processes entire sentences at once using the self-attention mechanism. So it's more powerful than recurrent neural networks and long short-term memory. Key transformer models. BERT, best at understanding sentence meaning. Example, knows that means fruit in I ate an apple, but a company in I bought an Apple phone. GPT, best for generating human-like text. Example, used in ChatGPT for conversations. T5, best for summarization and translation. Example, converts long text into short summaries. Deep learning makes text prediction smarter, faster, and more accurate. Applications of text prediction. Search engines, such as search terms as you type, helps refine searches for better results. Example, typing best pizza may suggest best pizza near me. Messaging and email. Smart compose. What does this mean? Suggest entire phrases while typing. Looking forward to your response. Can be an example for messaging and email. Saves time and reduces typing effort. Third, chatbots and virtual assistants. It's used in Siri, Alexa, ChatGPT to provide quick responses. Understands and predicts user intent for better conversations. Translation systems. Google Translate Deep Learning predicts the best translation based on context. Help with real-time language conversation. Content generation. AI-powered writing tools create blog posts, summaries, and even code. Example, GitHub helps developers write code faster. Challenges in text prediction. Ambiguity in language, bias in training data, computational complexity, privacy concerns. Ambiguity in language. Words can have multiple meanings based on context, making predictions challenging. Example, bank has a financial institution versus a river bank. Bias in training data. AI models can inherit amplified biases present in the training data, leading to unfair or inaccurate predictions. Computational complexity. Advanced models like transformers require significant computing power, making real-time processing expensive. Privacy concerns. Text prediction systems may store and analyze user data, raising concerns about data security and confidentiality. Future trends in text prediction. So now let us see the future trends in text prediction. Improvements in transformer models, real-time adaptation and personalization, cross-lingual and multi-model text prediction, ethical AI and bias mitigation. Let's go through each. Improvements in transformer models. Future models will be more efficient, reducing computational costs while improving accuracy. Real-time adaptation and personalization. AI will learn and adapt to individual user writing styles for more accurate and personalized prediction. Cross-lingual and multimodal text prediction. AI will predict text across multiple languages and integrate text with images, speech, and video. Ethical AI and bias mitigation. Ongoing research aims to reduce biases in AI prediction, ensuring fairness and inclusivity in text generation. So now I'm going to conclude this topic. Text prediction is revolutionizing communication and automation. Deep learning models like transformers have significantly improved accuracy. Challenges remain visions, privacy, and computational efficiency. Future advancements will continue to enhance text prediction systems. As AI technology advances, we can expect predictive text to become even more contextually aware, secure, and versatile. Predictive text is transforming the way we communicate, making typing faster and easier while adapting to individual preferences. So, in the case of ending the predictive text, in the settings menu, locate predictive text and click the slider to turn it off. Thank you.